Hello friends, today we'll study the types of electrical energy sources, and these types are alternating current and direct current. So alternating current means AC, direct current means DC, and these types are defined based on the change in amplitude and change in the direction of that signal. So first, what is amplitude? I can't define amplitude, but I can explain it. For an example, if you consider the light intensity, during daytime it is full, and at the night time it is almost zero. So that intensity of light, it brightens, it's nothing but its amplitude, its magnitude. Another example, if you consider the rotation speed of fan, so that speed of rotation of fan, it is nothing but the amplitude or the magnitude of that fan. Sometimes it is slow, sometimes it is fast. So that is what is amplitude. Amplitude is nothing but the magnitude, intensity, or the quantity which is present in that term. So here, if you consider AC signal or DC signal, the amplitude means the amplitude of voltage or current, right? What is the voltage, whether it is changing or it is constant. Second, is there any change in the direction in the flow of current? That is nothing but whether the current is unidirectional or bidirectional. Based on that, we are defining AC and DC. So when you plot any graph, what is graph actually? It is two-dimensional figure. There is y-axis, there is x-axis. On y-axis we plot the amplitude, that is magnitude, and we are plotting it with respect to independent quantity, and that is obviously the time. So let us plot the AC signal. So when I plot the electric AC signal, its amplitude, say voltage, with respect to time, there is change in amplitude as well as there is change in direction. So here you can say this is the AC signal. In this AC signal, from 0 to pi, pi to 2 pi, 3 pi, up to 4 pi, you can see here, there is continuous change in the amplitude from 0 to peak, positive peak, again 0, then negative peak, then 0. So there is continuous change in amplitude as well as there is change in direction. In one half cycle, the current flows from one terminal to second terminal, while in another half cycle, the current flows from second terminal to first terminal. But what is DC now? In DC, if you plot the DC signal here, the voltage of DC signal with respect to time. So there is no change in amplitude, there is no change in direction. Say it is 10 volt DC. So here you can see that there is no change in amplitude as well as there is no change in direction. That amplitude can be either positive always or it can be negative always. So this is DC. AC signal, DC signal. So these are classified based on two terms, the change in amplitude and change in direction. Here the two terminals in AC are phase and neutral. That is live terminal, which is also known as phase, and second is neutral terminal. In DC, the two terminals are positive and negative. So in DC, there are two terminals, positive terminal and negative terminals. What is positive terminal? It is always at higher potential, while the negative terminal is always at lower potential, and we know that current flows from higher potential to lower potential. So that is why in DC the current flows from positive terminal to the negative terminal outside the source, and inside the source, as it is current flows to the closed path, inside the source it flows from the negative terminal to the positive terminal. So that is the flow of current, and it is during discharging. But if we consider here in AC, there are two terminals, phase and neutral. Neutral is near about zero potential. Its potential is near about zero, not exactly zero. And phase potential, it changes with respect to time. What is this AC signal actually? This AC signal, it is nothing but VPN, which is voltage at phase terminal with respect to voltage at neutral terminal. Neutral potential is almost zero, which is constant. It is not changing. The phase potential during positive half cycle, it increases above neutral, right? So that is why during positive half cycle, the phase potential is greater than neutral potential. Hence, the current flows from phase to neutral during positive half cycle. During negative half cycle, the phase potential is less than neutral potential. So that is why neutral is at now higher potential as compared to phase. Hence the current flows from neutral to phase during negative half cycle. Hence here the current is bidirectional. And the source of the AC is nothing but the generator, and the source of DC is nothing but the battery, or in our lab we are having regulated DC power supply. In next video we'll see what is exactly DC and what are the potential at positive and negative terminal practically, as well as what are the different terminals, which are the different terminals in AC, that is phase neutral and one additional terminal earthing, and how to verify them practically. Thank you.